Good day, everyone. This is the continuation of our discussion about the topic solid mensuration. So the topic for today is all about triangles. So under triangles, so we will be dealing about the parts of the triangle, congruent triangles, similar triangles, the classifications of triangles about or according to their sides, and probably angles. Then we will be dealing with the altitude, median, and also the angle bisector, and some formulas regarding the area of the triangles. So let's proceed. So what are triangles? So probably triangles are the fundamental subset of polygons. So triangles are polygons with the least number of sides, and these polygons are widely used in the field of mathematics and engineering. So classification of triangles according to their sides. Probably you have the equilateral triangle whose all sides or all the three sides are congruent, and also it has uh, three congruent angles, and all of these angles measures 60 degrees. Equilateral triangle can also be called as equiangular triangle. Next would be the isosceles triangle, which have two sides that are congruent and two congruent angles. These angles, okay, are opposite of, of those two sides. And also these are called probably base angles. And scalene, a triangle with no congruent side and no congruent angles. As shown here, none of the sides are congruent or equal. And classification of triangles according to their angles, we have the right triangle, which is the most common, the triangle that has a right angle or a 90-degree angle. We have an oblique triangle with no right angles, and under these oblique triangles we have three. One of them is the acute triangle with no right angle, and probably we have equiangular, or we can call this one as equilateral when it is classified according to their sides. Okay, so the each of the angles, okay, or interior angle of the equiangular triangle is measured as 60 degrees. And lastly is the obtuse angle, which has one of the angle is an obtuse angle which measures more than 90 degrees but less than 180, and the other two angles are acute angles. So congruent triangle. So the word congruent is derived from the Latin word congruere, which means agree. So based on the given figure, you have two congruent triangles when they have the same size and also shape. And the corresponding parts of the congruent triangles are congruent. For example, those sides, similarly on this side, corresponding sides, and also the angles. And the symbol for the congruence is provided here. So about similar triangles, okay, this has been discussed under the polygon, which is similar polygons. Okay, they don't have the same shape, okay, but can be used for their corresponding sides or angle. So since the two triangles are similar, then the relations that exist between them are between the two similar polygons. Okay, thus it holds the following: any two corresponding sides are equal. Okay, so for example, side A1, okay, so the ratio of any two corresponding sides are equal. Like for example, side A1, okay, the ratio of A1 and A2 as shown in the given, all of is will be equal to the corresponding side of B1 and B2. Similarly, you can use A1, A2, and C1, C2, and similarly B1, B2, and C1, C2. Okay, then okay, for the area, okay, so the ratio of the area can also be equal to the square of any two corresponding sides. Okay, and then for the perimeter, okay, so the ratio of the perimeter can be equal to the ratio of any two corresponding sides. Parts of the triangle, probably you have uh, a triangle with three sides can have three possible bases, okay, and also three possible vertices. So any of the three sides of the triangle may be considered as the base of the triangle, and the angle opposite the base is called vertex angle. The two angles adjacent to the base are called base angles. So if you have recalled the given figure under the isosceles triangle, you have the angles, okay, uh, measured theta, okay, those are called base angles. So probably that's an example of it. And a line segment that is drawn from a vertex perpendicular, okay, to the opposite side is called altitude. Altitude can also be called as the height of the triangle. Okay, so the point of intersection of the altitudes of a triangle is called orthocenter. Later on, we will be dealing with centers of triangles. Okay, so as you given here, you have this triangle and a line segment that is drawn from a vertex and that is perpendicular to the opposite side. Okay, you have three line segments drawn perpendicular, and also similarly to this vertex up to this opposite side perpendicular line, and the point of intersection of those three line segments or perpendicular line segments can be called as orthocenter. So continuing with the parts of a triangle, you have the median. So the median of a triangle is the line segment connecting the midpoint of side and the opposite vertex. So the centroid is the point of intersection of those medians. While the angle bisector divides an angle of the triangle into two congruent angles and has endpoints on vertices and endpoints. So the point of intersection of the angle bisectors shown in the given figure is called incenter. So notice that angle bisector. Okay, so for example, angle B, if you draw an angle bisector here, you divide that angle B to two equal angle or two congruent angles. Similarly, if you draw at vertex C and vertex A, and the point of intersection of those angle bisectors is called incenter. So a perpendicular bisector, A of a side of a triangle divides the side into two equal congruent segments. So unlike the angle bisector, it divides it to two congruent angles, while the perpendicular bisector, the side is divided into two congruent uh, segments. For example, this one, okay, you have this given figure. If you're going to draw a line, okay, that is perpendicular, okay, to the side, okay, to any of those sides, and dividing that side to two equal length or two congruent segments, and their point of intersection is called circumcenter. Properties of triangle centers, you have orthocenter. Okay, you have, this has been discussed. So the orthocenter is not always in the interior of the triangle. So probably this is one of the facts. And then in an obtuse triangle, the two sides of the obtuse angle and the corresponding altitudes are extended to meet at the point outside the triangle. So while in the right triangle, the orthocenter is on the vertex of the triangle. The centroid. Centroid is known as center of mass of triangle. Unlike the orthocenter, the centroid is always inside the triangle. And for right isosceles and equilateral triangles, the centroid is located 1/3 of the altitude of the base. So probably this is another fact and can be used as a given. Then in center, so in center is the center of the largest circle that can be inscribed in a triangle, while circumcenter is the center of the circle that is circumscribing a triangle. So it is not always inside the triangle, and the vertices of the triangle lie on the circle and are equidistant from the center. So yeah, we have here the altitude, median, and the angle bisector formulas. So let's talk about the altitude. So by definition, altitude, or the synonym of altitude, can also be called the height of the triangle. You have this formula, altitude, okay, based on the from vertex C, okay, as shown in this given figure. You have this formula that is twice the square root of the products, okay, of S, where S is called the semi-perimeter, and we have this formula. ABC corresponds to the sides of the triangle. So S minus A, B, and then C, and the denominator should be the opposite side, okay, where the line segment is drawn that's perpendicular to that corresponding side. So if I'm going to draw, if like for example, my base is A, I draw a perpendicular line, okay, from the vertex A and to this given side. So my base now will become side A. So this is height A, at point A or at side A. So the median is given by this formula, okay? So that is 1/2 the square root of twice the square of A side plus twice B, or the B side, square of the B, and then, or side B, and then subtract, okay, uh, side C, or the square of side C. Based on this given formula, okay, the median, okay, it divides the side or opposite side from a given vertex to two equal segments. Okay. So the measurement from the vertex up to this point C is measured by this given formula, using the median formula. And also an angle bisector. So by definition, angle bisector, it divides the angle to two congruent angles. You have this formula and it's denoted as L. Okay. And this one is the given figure. Okay. So for this particular figure, by means of angle bisector, angle C is divided into two congruent angles, or probably two equal angles. Okay. So that gives us this formula. Okay, you should memorize them. Okay, so probably memorize them by heart. Okay, you have here side A, B, or the product of A, B, and then the sum, right, of side A and B, okay, then squared, and then C squared, and then the uh, denominator, right, will always be the two sides, okay, that doesn't meet with the given side. For example, I draw a median from vertex A going to side A. My denominator probably will be B and then C. Okay, and then AB here will be changed to B, product of B and C, and then B plus C minus, probably this is A squared. Okay, so just simply refer to this given figure. Now we have the formula for the area of the triangle. We have 1/2 base multiplied by the height. So this is the most common formula for uh, triangle. You have the base represented as B, and age is represented by the altitude, also known as the height of the triangle. So for this particular figure, This can be denoted as height that is perpendicular to your base. And of course, this one is called base. Similarly with this one, this is the length of your base, and probably this is the height or altitude. So the next formula is called SAS formula, which gives us, if the given triangle is giving us two sides and an included angle, you can use this formula. So that is the 1/2 the product of any two sides, okay, and the sine of their included angle. Okay, so for this particular problem or figure, you have two sides, sides A and B, and the included angle is theta, okay, or angle. And then you have this formula, 1/2 the product of side A and B, and the sine of their included angle. And lastly, this is the Heron's formula, which is just for the three sides given. Okay, you have this formula. Okay, so if all the sides of the triangle or the three sides of the triangle is given, you can use this formula. Take note that S represents semi-perimeter and sides A, B, C are the sides of the given triangle. That is divided by 2. So we all know that perimeter is the sum of all sides. Okay? So semi-perimeter, you divide it by 2. Take note when you draw triangles, uh, the angles are represented by capital letters. Angles A, B, and then C. And their opposite sides, or the opposite sides of the triangle represents this, or the opposite sides of the angles are the sides which corresponds to A, which is represented this given figure, which is opposite of angle A, and B, side B, is opposite of angle B. Similarly with side C, that is opposite of angle C. So those are the three formulas. So we have here illustrated problems. Let's proceed to problem number 1. So find the altitude of and the area of an equilateral triangle whose side is 8 centimeter long. So again, I'll repeat the problem. So find the altitude and the area of an equilateral triangle whose side is 8 centimeter long. So we need to find the altitude or the height of the triangle and the area of the triangle. So based on the given, you have an equilateral triangle which has a definition of all sides are equal. Then you can simply draw that given figure or draw that given equilateral triangle. Use your imagination. Okay. So let's draw a triangle. So whose sides are centimeter long? Whose side, okay, given one side, is 8 centimeter long. Since it is an equilateral triangle, so all sides are equal. You have 8 centimeters, 8 centimeters, and 8 centimeters. Now, you have this one line here, and that is represented by height, and it is perpendicular to the base. And we also know that uh, the angle, okay, for an equilateral triangle is uh, given as 60 degrees on all of its interior angles. And the required is the altitude of the triangle or height, which is represented as h in the given figure, and the area of the triangle or equilateral triangle. Take note that capital letter A here doesn't represent area. Okay? It represents angle A, probably, and probably this is angle B, and that would be angle C. So angles are represented by capital letters. So probably you could have a right triangle, right? That is referring to this given figure. I could get a right triangle. So if I'm going to get this right triangle, red draw it here, and provide the given as shown on this original given figure. You have the altitude, which is represented as age. You have this side here, 8 centimeter, angle 60 degrees, and probably this is divided into two equal segments. So this gives me 8 all over 2. That gives me 4 centimeter. Okay? So you have here a right triangle, and we can now simply determine uh, the height by means of two approaches. Probably you can use uh, the most common, which is the Pythagorean theorem, or you can use the trigonometric functions like sine, cosine, or tangent. So for this particular problem in solving for the height, I have used the Pythagorean theorem. Okay? So the Pythagorean theorem is represented by this formula. That is, the square of the hypotenuse is equivalent to the sum of the square of the other two sides. Okay, so you have here the hypotenuse side, which is represents the uh, longest side of a given right triangle. And take note that Pythagorean theorem can only be used when you are given two sides of a right triangle. So specifically, Pythagorean theorem can only be used in a right triangle. Okay, so rearranging, solving for the unknown. So for this particular given figure or right triangle, we have the given 8 centimeter for the hypotenuse. Okay, and then let's say this is side B, probably. Okay, we have angle A, so probably this is side A when represented on this given formula. So therefore, by substitution, or you can simplify this one first. Okay, you have a altitude is represented by the side A, okay, and then will be equal to the, okay, you have here the square root. Okay, I have taken the square root of both sides, okay, in order for me to eliminate the exponent 2 here. Okay, then you have the hypotenuse, which is 8, and then you have side B, which is given as 4 centimeters. Then simplifying, you get the altitude as 4 square root of 3 centimeters. So this is one of the unknown or required. So we have answered the height of the or altitude of the equilateral triangle as given 4 square root of 3 centimeter. Now we need to solve for the area. In solving for the area, okay? Wait, also I would like to show you the solution using the trigonometric function. You have sine, cosine, or tangent, but that depends on the given. Okay, so for example, we have sine of a given right triangle. So the sine is represented as opposite all over hypotenuse. Or you can use cosine, which is the adjacent, or I mean tangent function, okay, as represented by opposite side all over the adjacent side. By definition of the cosine, that is the adjacent all over hypotenuse. So they are given. Okay, so I'll be using sine function. If you wanted, you can explore. You can use probably tangent, which is opposite all over the adjacent side. So I'll be using the sine function. So sine angle, okay, or sine 60 degrees, which is opposite, okay, which is represented by altitude, and then all over 8, okay, which is hypotenuse. Okay, so simplifying or rearranging this formula to solve for height, we get these equations. So 8, the product of 8 and sine 60 degrees. Using your calculator, okay, you will be arriving with the same answer, 4 square root of 3 centimeters. Now, solving for the area of the triangle. Based on the given, you have the uh, all this altitude. We have the altitude now. Okay, so the I could use the most commonly used formula, which is the one half, or product of one half and base and the height. So you have the base, okay? So I'll take note of this formula, okay? Or this given uh, required or the required, which is the area. So we will now refer to the original given, okay? So in solving for the area, you should always go back to the original given. So I'll be using 1/2, then base, and then the height. I'll be using base as 8, and height or altitude, I'll just be using this one. So substituting all the given, I have 1/2 and then 8 for the base, and then 4 square root of 3. Okay. By the way, if you're going to use this triangle, 1/2 and then base multiplied by height, you only get the half of the area, half the area of the original triangle. You need to multiply that by 2. So simplifying this, you'll get 16 square root of 3, okay, square centimeters, or you could use that in decimal place, 2 decimal places probably. So that is also equivalent to 27.71 square centimeters. So final answer, okay, you have the altitude for square root of 3, and either of the two can be used for the area of your triangle, 60 square root of 3 or 27.71 square centimeters. Now, problem number 2. One side of an isosceles triangle whose perimeter is 42 inches. It measures 10 inches. Find the area of the triangle. Okay, once again, I'll just read the problem. One side of an isosceles triangle whose perimeter is 42 inches measures 10 inches. Find the area of the triangle. So, based on the problem, what are the given? So probably you have an isosceles triangle, okay, whose perimeter is 42. So the perimeter of the triangle is 42. And one of the side of the triangle it measures 10 inches. So find the area of the triangle. So by definition, isosceles triangle has two congruent sides and okay, two congruent angles, right? So based on the given problem, the given is one side. Okay, so probably that is not the call this the two congruent side because it only stated as one side of the triangle measures 10 inches. So I just use the given isosceles triangle. So I just provide the given, draw the triangle. I would arrive to this given figure. You have one side whose measures 10 inches, okay, and the two congruent sides are unknown. Also, one of the given is the perimeter, which is equivalent to 42 inches, and the required is the area of the isosceles triangle. So how are you going to approach this one? Okay, so based on the given, you have this uh, value, which is 42 inches. That is the perimeter. So solving for the unknown sides, which are represented here as x, okay, you can use this given as 42 using the formula for perimeter. And we all know that perimeter is the sum of all sides. So probably side A, side B, and then side C. You have one given, okay, which is 10 inches. So I'll just substitute the sides. I could substitute x for A, x for B, and probably C is 10. Okay, so either which of the arrangement, okay, can be done. So substituting the given, I have 42 for perimeter, and then I use 10 for A, and then I have the two sides of unknown. Then simplifying this, okay, you have twice the x, and that is equal to 32. dividing both sides by 2, or probably multiplying both sides by 1/2, you'll get the value of x, which is 16 inches. Okay, so probably this side is 16 inches, and also this side is 16 inches, because these two sides are congruent. Then solving for the area of the given triangle. Okay, based on the given, I have now, okay, 3 sides given, so I could use Heron's formula. Okay? So that gives you this formula, and S represents semi-perimeter, and A, B, and then C are the sides of the given triangle. Okay? Solving for the semi-perimeter. Okay, so substituting those sides, we'll have 10, 16, 16, and that is divided by 2. And then simplifying this, you'll get an answer of 21 inches. Substitute this value to this form for the formula of the area. You have S, which is equivalent to 21, or the semi-perimeter. Similarly, this is 21 minus A. So A I have used as 10, and then 21 minus B, which is 16, and then 21 minus 16. Okay, so substituting them, then simplifying, okay, you have an answer of 75.99 square inches. Make sure you provide the unit, as it would determine the correct unit for the given unknown. Okay, so the final answer for this one, okay, is 75.99 square inch, or that can be rounded off to 80 square inches. Proceeding to the next problem. So the ratio of the base of an isosceles triangle to its altitude is 3/4. So again, you have an isosceles triangle, so you should be familiar with this triangle by now. Okay, so the ratio of the base and the altitude is 3/4, or 3:4. Then find the measures of the angles of the triangle. So if you're familiar with triangle, 3 vertices, so probably we will be solving or determining the angles of triangle, which is angle A, B, and then C. That is represented in the given figure. So based on the given, you have an isosceles triangle. So let us draw an isosceles triangle with 2 congruent sides, okay, and 2 congruent base angles. Okay, so this is called the base angle. Okay, so side AC and side BC are congruent. They are equal in terms of measurement. So the opposite sides of those 2 congruent angles are congruent angles, which is A and B. And these angles, which is A and B, are called base angle. Now, the angle opposite the the base, okay, is called the vertex angle. Okay, so the ratio of the base and the altitude, or to its altitude. So again, that is also a given, probably. So the ratio of the base and the altitude is 3:4, or 3/4. Okay, that is also a given. Any more given? So probably none. So the required, right, will be the angles of the right triangle, which is angle A, angle B, and angle C. And as you notice here, I have provided you some of the definitions. So B is the base of the right triangle, or the triangle, I mean. And then H, it represents altitude or the height. Then A, B, and C, which are capital letters, are the angles of the triangle. Okay. Now, based on the solution, we have no other given but for this one. Okay. Okay, so the ratio of the base and the height. Okay, so we can say, so since we have an isosceles triangle, we can say that angle A is equal to angle B, probably. Okay? And similarly with side AC is equal to side BC. So I'll just use the angle. Then from the given equation, we can solve for the base of the triangle. So the equation I'm referring to is the ratio of the base and the height. So using that equation, it is solving for the base by means of multiplying both sides by height or altitude or age, you'll arrive to this given equation. So let us denote this as equation 1. Okay. Then from the given figure, we can get a right triangle. Okay. So any of the two right triangles can be drawn. Okay. So I'll just use angle B, okay, as my reference angle here, and then height. That this is B all over 2. This can be represented as C. Okay. So that is angle C. Okay. So since you have right triangle, based on the given, you have the height, and then base is divided into two equal segments. Okay. Uh, what function should I use if I am given height or altitude and base with this value? So this is the opposite, and this is the adjacent side. So I could use a trigonometric function called tangent. Okay, tangent of angle B is given as opposite all over adjacent side based on this given. Now simplifying, okay, so tangent B, angle B is equivalent to twice the height all over B. Okay, now I have a value of B, which is this one. So I'll just substitute the equation we have to this given uh, equation. So you have now tangent B is equivalent to 2h, which is this one. And then B, based on equation 1, it is equivalent to 3/4 of the altitude, as shown here. Now, age or height divided by height, that gives us 1. Okay, so you can simplify this equation, you get 8 all over 3. Then dividing both sides by tangent, okay? So B now will be equal to the arctangent of 8 all over 3. And angle B, simplifying that using your scientific calculator, you'll get an angle of 69.44 degrees. And that is one of the angle, as no unknown here. Now, I have said earlier, since we have an isosceles triangle, okay, the two base angles are congruent, which is angle A and angle B. So probably the value of angle A is 69.44 degrees. Now solving for the last unknown angle, right? You can recall that the sum of interior angles of a given triangle, okay, is equivalent to 180 degrees. So again, I repeat, the sum of the interior angles of a triangle is always 180 degrees. You have angle B, which is 69.44, and then angle A is also 69.44, and you can solve for angle C. So rearranging that equation, you get this given equation. So the angle C is equivalent to 180 degrees minus angle A and minus angle B. Substituting the given values, 69.44 for A and then 69.44 degrees for B. Simplifying that, you'll get an answer of 41.12 degrees. And that is the answer for angle C. So the three angles are 69.44 degrees, and 41.12 degrees. Next problem is problem number 4. So the base of an isosceles triangle, okay, and the altitude from one of the congruent sides are equal to 18 centimeters and 15 centimeters respectively. Find the lengths of the sides of the triangles. So the unknown is the lengths of the sides of the triangles. So based on the problem, okay, if you didn't get the given right away, you may need to read again the problem. So the base, okay, of an isosceles triangle. So probably this is a given isosceles triangle. Then the base and the altitude from one of the congruent sides are 18 centimeters and 15 centimeters respectively. So 18 centimeters is given as your base, and the altitude from one of the congruent sides is 15 centimeters. You have here the word respectively based on this given sentence. So on the given, an isosceles triangle. Okay, you are familiar with this one, two congruent sides, two congruent base angles. Okay, have this given figure. I have here the isosceles triangle, and then the base is 18 centimeters, and the altitude from one of the congruent sides, okay, are or is equal to 15 centimeters. So I have chosen this side. We all know that altitude, okay, is drawn from a vertex going to the opposite side. Okay, so that is a perpendicular line as always. So you can always draw a given figure. Like for example, I have drawn an altitude here, okay, then 90 degrees. You can also use this side because this side is also one of the congruent side. So you can draw opposite, okay, then 90 degrees, so that will be the altitude. Okay, so you have here angles A, B, and C. Okay, and then line segment AD represents the altitude 15 centimeters. So A represents side BC, then B or side B represents side AC, and side AB is represented by side C, which is the base of the given isosceles triangle, which is 18 centimeters. So find the lengths of the sides. So we already have one. Okay? So we only need to determine side A and side B. But then, since this is this is an isosceles triangle, we can also say that side A is also equal to side B. So we need to only determine one of the sides here. Okay. Now, so capital letters A, B, and C represent angles, and side A, B, C are represented by small letters. Required, okay, you have side A, side B, it's a noun, and then you have already given 15 centimeters. So this is still an answer for this particular problem. Okay, so find the lengths of the sides. So there are three sides, so you have three answers. So side A, side B, and then side C. So based on the given, okay, probably I'll just yep, a right triangle. Okay, so I have two right triangles here. Triangle ABD and also triangle ACD. Since this is perpendicular angle, okay, this is also a perpendicular angle here, okay, or 90 degree. So since we have an isosceles triangle, we can say that angle A and angle B are equal. Okay? Similarly with side A and side B. Okay. So based on this given, we can get a right triangle. So for this particular given, I'll just use A, B, and then D. Triangle ABD. This one. And then I'll denote, right? I have noted here side BD from this part here is represented as side X. Okay, I cannot denote this as A. Okay, Uh, uh, you might have a question. From the discussion, you told us earlier that uh, the opposite, okay, of the angle is represented by small letters. I have already used that one here, okay, based on the original given. Now, based on this one, since I have already gotten this from this given figure, I just represent this as a new uh, variable. So for this particular variable, I have placed x, okay, for the unknown side. Okay. Now, based on that given, okay, you can determine x, okay, side db or bd, and also probably angle. You can determine the angle using a trigonometric function. Okay. So let's continue. So using Pythagorean theorem to solve for the unknown value, you have the hypotenuse side based on this right triangle. Okay. So you have the hypotenuse and then side A or B, either which of the two you can use. So the unknown is the other side here, x. So by means of the square of the hypotenuse is equivalent to the sum of the squares of the other two sides. So since the unknown is not the hypotenuse, right, one of these given is unknown. So I can use uh, one of those, okay, in order for me to arrive to this one. Right? So the side x is equivalent to the square root of the square of the hypotenuse minus uh, square of the other side here, which is 15. Simplifying that, you'll get an answer of 9.95 centimeters. So probably this measurement is from B to D, this side only. Okay. Now I could solve for the angle B, okay, using sine function. Sine of angle B, right, this is a right triangle sine, reference angle is B, this is the opposite side, and then this is the hypotenuse. So opposite hypotenuse, that's the given. Then dividing both sides by sine function, okay, you get arc sine of 15 all over 18. And simplifying that, you get an angle of 56.44 degrees. And probably this is also equal to this value. Okay, so from this particular solution, similarly, this is applied if you're going to if you're going to provide a given on this one as the altitude, then you can solve for angle A, probably. Okay, so for this particular one, this is also equal to angle A. Okay, then recall that the sum of the interior angles of a triangle is equivalent to 180 degrees. So similarly, you can solve for a angle or unknown angle that gives us a value of 67.12 degrees. Now continuing, so based on the previous solution is continued. Okay, so based from the given, I have gotten this right triangle. Solve for the unknown side here, or length of this side, which is BD, is 9.95. Angle A and B are equal, and then angle C is given 67.12. Now, let us now consider triangle ABC. Okay, this right triangle. Okay, so based on that given. So since side BC has a length of A, okay, so we need to determine this value of DC, okay, by means of the whole length, which is A, minus the length here, which is BD, and that is represented by X. So A minus X. I have here the, call this, I have here the angle, right? So there are so many possible solution, okay, in determining this one. I could simply solve for side AC, okay, to solve for side B, and then side B will be equal to side A. So for this particular problem, I would like to use X here and the angle C. Okay, then using a well, this trigonometric function probably to solve for A. So I'll just use tangent C, because the given based on this right triangle is 15 centimeter, which is the opposite side, and then the adjacent side is A minus X, shown here. And then substituting the values 67.12, then 9.95 for X, simplifying this equation, solving for A, you'll get 15 divided by the tangent of 16.12 degrees plus 9.95. So probably the measurement of side A is 16.28. Referring to this one, side A is the full length of this side, which is side B going to C. And since we have two congruent sides, we could say that uh, side A will also be equal to side B, okay, which is 16.28 centimeters. So final answer. So the sides of the isosceles triangle are 18.28 centimeters, 16.28 centimeters, and 18 centimeters. So this will be your final answer. Another problem. So problem number 5. So find the area of a triangle if its two sides measures 6 inches and 9 inches, and the bisector of the angle between the sides is 4 square root of 3 inches. So you have two sides given, and then you have this angle bisector, okay, which is 4 square root of 3 inches. So based on the given, the triangle is not specified as right. Oh, so this isosceles, equilateral, and so on. So you need to approximate the length of the sides of the triangle based on the given. So if I'm going to draw that one, I would arrive to this given figure. We have here, okay, the two sides measure 6 inches, 9 inches, and then you have this angle bisector, okay, which I have drawn from vertex C, okay, and then you are dividing the angle by to two equal or two congruent angles, and angle bisector is given as 4 square root of 3. So the unknown is the area of the triangle. Okay, so find the area of the triangle. So that's the required. Okay, so using that one, you have here, okay, for the solution, you have um, this given 4 square root of 3, which is the angle bisector. Okay? And for that angle bisector, you have your formula for the angle bisector. Okay? Then you have the square root of the product of A and B, then sum of these sides, square, and then C squared, which is the base, and then A over B. Now, what are we going to solve? Area, right? So for this particular problem, probably this is A and B, and the unknown is C. We have the angle bisector, which is this one. Okay, uh, so simplifying that equation to solve for C. So multiply both sides by A plus B, then and then squaring both sides probably. Okay, so I square both sides to eliminate the radical sign here. Okay, and then dividing both sides by the product of AB, okay, to arrive to this equation, and then simplifying the equation. Okay, so I could add C square on both sides, and then I could subtract this one. Then simplifying, arrive to this given equation. Okay, so substituting all the given, then taking the square root of both sides. Okay, you have this equation, then substituting all the given values, you have a and b, and then square for square root of 3 for the angle bisector by 6, then product a and b. Simplifying using your calculator, you have square root of 25, and that gives us a 5 inches for this given side. Okay, now continuing. Okay, so since we have solved for the unknown side, you have to get to use a formula for a triangle, which is given three sides probably. Using Heron's formula, okay, you have this formula, and S is the semi-perimeter, which gives us this equation. So S is semi-perimeter, A, B, and C are the sides of the triangle. Solving for the semi-perimeter will have 10 inches. Okay, and then substitute this value to the given Heron's formula, which is S, which is semi-perimeter, and then the A, B, and the C, or sides A, B, and C. Okay, we'll have this equation. Then simplifying, okay, you get product of 10, 1, 14, and 5. Okay, so you have an answer of 10 square root of 2 inches, or square inches. That is for the area of the triangle, or in terms of decimal, we use two decimal places. Probably that is 14.14 square inches. So probably there are so many ways, or probably what I have discussed here are just some of the possible ways to solve for the unknown or the required. Okay, make sure to always base your solution uh, on the givens of on the problem. And then based on those given, you could arrive to a possible solution, or based on a given formula. Okay, so if you have any other ways to solve these given problems that is much even easier for you to understand, you can do so. Again, these are some possible ways to solve the given problem. And also, I would like to give you a tip. Okay, make sure you may want to draw a given figure and then place those givens in the figure itself. Now let's try this one. Okay, so probably this will be one. This is another problem which I didn't solve. Okay, so you may need to try and learn probably by doing. Okay, so the measures of the three sides of a triangle are AB. Side AB is equivalent to 13 inches, side AC is equivalent to 50 inches, and side BC, which is equivalent to 60 inches. From a point D on side AB, based on this side, okay, so a line DE is drawn through a point E on side AC such that angle angle AED is equal to angle AB and C. If the perimeter of the triangle ADE is equal to 56 inches, find the sum of the lengths of the line segments BD and C to E. Okay, so for this particular problem, you may need to draw the triangle itself. After drawing these triangles, okay, so for example, side AB 30 inches, side AC 50 inches, and side BC 60 inches, you may want to approximate their lengths based on your drawing. Okay, so for example, side AB is 30, side AC, so from vertex A to C is 50 inches, so probably that is much longer to side AB. And then when you draw side BC, which is 60 inches, so side BC uh, probably is longer than the two sides of the given triangle. Then you start drawing from a point D on side AB. Since you have drawn AB, you can draw a point, right? And then a line D going to E is drawn from to a point E on side AC. So you have point D here and then point E on side AC. And then you can do the rest if you want to. So you may need to practice. Okay, I think that's all. Okay, so thank you for this another topic. Okay, so hope you enjoy and probably learn something about triangles. So for our next topic, those are quadrilaterals. Quadrilaterals are four-sided polygon which can be represented by a square, a rectangle, a rhombus probably, and probably a trapezoid. So see you next meeting.